Is this on? Yeah. There's been no shortage of tech press coverage, case studies, blogs about some huge success of moving to the cloud over the years. But I believe that public cloud adoption is only now reaching critical mass, where it's become to the point where it's interesting and impactful. And it's because that point is where not only the tech bleeding edge companies are able to adopt cloud, but so are the rest of the world, are able to go ahead and adopt cloud at scale and to impact. That $250 billion public cloud market by 2020 is not going to happen through just the Spotifys, the Netflixes, the Snapchats of the world. And we should stop pretending as if it will. Furthermore, the Spotifys, the Netflixes, the Snapchats, and the Googles for the matter, while we'll continue to invest in pushing that edge, at scale also want to hide the complexity toward stability and repeatability. My goal here is to set that expectation as we turn the corner in public cloud adoption, that cloud ecosystems have to work at scale for everyone. And until it does so, we'll never reach the world-changing success that it aspires to become. Neither of the computers are. That's funny. Like, that's not my presentation either. In the meanwhile, another reality is that the cloud is changing too. We are increasingly moving toward something that's called cloud native, sometimes referred to as cloud v2. And infrastructure as a service offered us capabilities we didn't have before. But fundamentally, it was the same technology with a different operating cost model. Cloud native technologies like Kubernetes, for example, are aiming to take full advantage of the scale and the flexibility that cloud offers in a way that infrastructure as a service never could. But it brings with it a new order of complexity and a new ramp to productivity, and that trajectory will necessarily continue going upward. So what does that mean for developers? Do we need to all learn a new set of primitives, nuances around edge cases, better YAML templating systems? And I think the answer is hopefully not. You've all read a lot of blog posts out there, people sharing the systems that they put together in order to deploy to a system, whether it's Kubernetes or OpenStack or whatever it might be. And some of them are reasonable, and some of them are Rube Goldberg machines. I think we've written a couple ourselves as well on the Spinnaker team. And you might be feeling the pressure that you need to be able to do the same in order for you to not fall behind the curve. And I am openly reminding all of us to something we agreed on years ago, that developers should continue to focus on feature code, that platforms should hide complexity, and that tools, not developers, should be solving domain-specific problems like CI and deployments. So let's take continuous delivery as an example. We say continuous delivery, its goal is to safely and frequently deploy changes to production. If you break down what a CD tool really needs to do well, it's actually really simple. It needs to help you manage the things that change so you can roll them out. It needs to give you visibility to the things that are changing and a way to validate that things are going well. And then third, when things go poorly, it needs to help you remediate when change goes badly. Now, I work on the Spinnaker team at Google, and Spinnaker is an open source project that we worked in collaboration with Netflix and many others. And we've worked hard to strike the right balance between exposing and surfacing the things that you want to manage in a very particular way, multi-regional rollouts, exponential rollouts, for example, promotion of code across environments, and black boxing the things that you shouldn't have to deal with and encapsulating those things. So a single confirmed deployment, for example, or more advanced things like automated Canary analysis. And this is the truth for all the other platforms out there, including whether it's AWS or Mesosphere or Kubernetes or OpenStack. But let me walk through a couple of examples with Kubernetes on how we need to go and how there's complexity in doing these things well and how we need to go ahead and abstract that successfully. So for example, in Kubernetes, when you have a binary change, you have a new Docker container, typically here's how you do it. You build a Docker container, put a tag on it. You open your Kubernetes manifest, and you go and update that section that says what the image tag is, and then you go and deploy it out to Kubernetes. Now, Spinnaker, as well as many other systems, can automate that for you. It can go and react to events from pub/sub messages, go and retrieve artifacts from source repositories like GitHub, and then go to make the call to deploy that out to Kubernetes. But if you think about what needs to be done here, it's about taking the event message's context, the event context. So for example, that pub/sub message might specify the new tag that was built, and then translating that into pipeline-specific context, and then injecting that at runtime into the Kubernetes deployment itself. It's about getting away from wrangling that Kubernetes manifest file every single time something changes, because this is better than manually wrangling it, which is error-prone. And it's actually even better than scripts or systems that might update that manifest for you, but don't carry through the process of confirming that the deployment was successful and following through by automating the process when things go well and when things don't. Okay, another example, config change in Kubernetes. In Kubernetes, configurations are done via config maps. So every time you have a configuration change, so your application parameter, a database password changes for your application. By the way, how many people have worked with Kubernetes here? Okay, great. So about half. The key idea here is that there are implementation details that your developer shouldn't have to go and wrangle. And that effort should not scale linearly with the number of development teams, the number of rollouts that you do. It should scale sublinearly. And that's what the developer should continue to go and expect. So we can go ahead and talk about details later, but that's not really important. Because then the key is that as you do things like, need to handle things like rollbacks, the system can handle for you as well. So you do a deployment, v001, looks good. Binary change, v002, looks good. Config change, v003, something went wrong. And what a tool like Spinnaker and what tools should be able to do is to go to mark a point in time where you have a known good binary and configuration combination that you can go and roll back to instantly. Not look up lists that you maintain, not go through code repository, commit history to figure out which YAML combinations you have to wrangle together to get a combination done. That's a simple example of hiding the implementation details for you. And then when you don't focus on the implementation details and you focus on the domain-specific problems, we can tackle problems like Canary analysis, so that when you go out and do rollouts, we're taking metrics and comparative approach to whether your applications are successfully rolling out or not. And there are many other things. And once again, the key point is, this is where you want the developers to interact with your systems, and not in the implementation details. So continuous delivery has a lot of momentum behind it. And if not done well, it passes on the burden and cost to the developers. And we think that there's a lot of work to be done here, but I hope you'll agree that this is good work to be done. So if you would like to join us, you can start by going to the website and checking out how you can get involved. And of course, throughout today and tomorrow, if you see me in the hallways, please don't be shy. Come by, say hello. I'd love to hear what you guys are working on and to share ideas. Thank you.